let's get right into it today. We're going deep on microservices,
Sounds good.
and I think a lot of folks listening are probably familiar with the basics at least.
For sure.
So we're going to go a bit deeper today.
Okay.
We've got this great in-depth guide we're going to be pulling from,
Awesome.
and we're going to really get into like the real world stuff.
I like it.
Like, where do you actually use these things?
Yeah.
Beyond all the kind of like
Buzzwords, yeah.
Exactly. So the guide starts off by kind of putting microservices head to head with the monolith approach.
Okay.
The classic kind of like battle.
Right.
What are some of the things that jump out at you from the guide in terms of like the pros and cons beyond the typical, speed and agility stuff?
Well, I mean, the guide makes a really good point that monoliths, they seem simpler at first, right? But once they start getting bigger, they get really hard to actually scale up and maintain.
You get that kind of like,
that huge code base and
everything's all tangled up together.
Too intertwined, exactly.
It's like one of those,
almost like a house of cards.
Yeah, like you change one thing over here,
right, and
then something else breaks over there.
Then something else over there breaks, yeah.
Yeah, exactly.
That's where the microservices shine because they break down those applications into these little pieces.
Right.
So that, if something needs to be updated or scaled, you can kind of do it more in isolation.
Yeah, I think that's a good point.
Yeah.
The guide also, though, points out that it's not like, all sunshine and rainbows with microservices.
Sure.
There are some potential downsides, too, right?
Yeah, definitely.
Like, what about, like, the complexity of having to manage all these different moving pieces?
Totally. And especially, like, the communication between them.
Oh, yeah, that can
get really complicated really fast.
Like, if you've got all these little speedboats all going different directions.
Right. You got to make sure they can talk to each other and aren't going to crash into each other.
Yeah. Yeah, they're all pointed towards the same destination, right?
Exactly.
So it's kind of like you're gaining in flexibility.
Sure.
But, you're also introducing a new set of potential trade-off for sure.
Yeah. To think about.
Yeah.
Now, the guide, it goes into actually building out microservices.
Okay.
And it uses this kind of interesting analogy of putting together like one of those high-tech Lego sets.
I like that analogy.
It's like you first got to figure out like what you're building.
You got to have a plan.
Yeah, like what's the vision
right
for your Lego creation?
Exactly.
And then it talks about dividing it up into
so like you got to define those boundaries between the services.
Right, like how do you break it up?
Yeah, where do you draw the lines between those different Lego pieces?
Like in that Lego city we were talking about, you have to think about like
what are the different
sections of our city? Like we've got transportation,
entertainment, residential areas, all these different things. Those are like our business capabilities, and then we have to break those down even further.
Right, and you got to kind of find that sweet spot between making those pieces small enough that they're manageable.
Right, so that they can be independent.
But not so small that they're...
But not so small that they're...
not doing anything meaningful.
Right, it's a balancing act, for sure.
And it keeps coming back to this idea of keeping things...
keeping it loosely coupled.
Loosely coupled, yeah. I mean, that seems like a pretty important concept.
Oh, incredibly important. That means that, those services aren't too dependent on each other.
Right.
Which means you can change one without breaking the others.
Yeah, kind of like...
like with the Legos, if you change one part of your Lego set, it shouldn't make the whole thing fall apart.
I don't want the whole thing to crumble.
Exactly.
So, all right. So we've got our vision. For the Lego city, we've kind of broken it up into these...
Our blueprints. Yeah, these blueprints. What happens next?
Well, now we get to actually start building, developing those services.
Yeah.
And the cool thing about microservices is that, you can have different teams working on different services.
Right.
And they can even use different programming languages and technologies.
So it's kind of like...
It's like having all these Lego masters with their own specialties.
And they can all kind of bring their own flair to the table.
But you still need to make sure that everything fits together in the end.
Right. Like if you have one team using like red bricks.
Yeah.
And another team's using blue brick.
Exactly. You need to make sure they can connect.
You got to make sure they can, connect and work together.
You got to make sure that you have those interfaces and the communication protocols all sorted out.
Yeah. So it's kind of like a universal set of... Instructions that everybody can agree on.
Exactly. So that even though you're using different tools and techniques, the end result is still a cohesive whole.
Right. And that's where I think the guide starts to talk about like the importance of containers.
Yes. Container
orchestration.
Very important.
And specifically like Docker and Kubernetes.
Ah, yes. Our dynamic duo.
I mean, it's like, those are like
they're kind of like the logistics of our Lego city.
Yeah.
Making sure that all those pieces get to where they need to be.
Like the shipping containers and the trains and all that.
And the trucks and everything.
Yeah. So maybe just for our listeners who might not be as familiar with those terms,
sure.
Can you give like a quick kind of overview of like what Docker is and what Kubernetes is and how they kind of play into this?
Absolutely. So think of Docker as the packaging for each of our microservices. So it's like taking each of those little Lego creations and putting it in its own little box.
Oh, okay.
And that box contains everything that Lego creation needs to work.
Like all.
So it has the Lego pieces themselves, any instructions, any little tools or anything that it needs. And then that box can be shipped anywhere.
So it's self-contained.
It's completely self-contained. Exactly.
Okay.
So that's Docker. Now, Kubernetes is like the mastermind
Okay.
that manages all of those Docker containers.
Oh, wow.
So it makes sure that all the containers are running smoothly.
Okay.
It makes sure that they can talk to each other. It can even scale them up or down if needed.
So it's like the air traffic control.
Exactly. It's like air traffic control for our Lego city.
For all those
making sure that there are no collisions.
Shipping containers.
Exactly.
Yeah.
Making sure that everything is flowing smoothly.
And that nothing's getting, lost or
Exactly.
broken along the way.
And if a container crashes, Kubernetes can even restart it automatically.
Oh, wow. So it's like it can even do like repairs and stuff.
Yeah. It's pretty amazing. It's like having a self-healing Lego city.
Yeah, that's pretty cool. And I think the guide mentions that it can even scale things automatically.
Oh, yeah.
Like based on demand.
Totally. That's one of the coolest things about Kubernetes.
I mean, that seems super important.
So it's critical.
Like if you've got like a big sale.
Yeah, or like a big product launch or something.
And you suddenly have like 1 million people trying to access your site or whatever.
It can just spin up more containers to handle the load.
Oh, wow. So it just kind of like.
And then when things calm down, it can scale back down again.
Oh, so it's like
So you're not wasting resources.
It's super efficient.
Exactly.
Wow. Okay, so we've got our services built.
We've got our containers.
We've got our containers. We've got Kubernetes managing the whole orchestra.
Right.
But then the guide also talks a lot about
architecture and design patterns.
Yeah, architecture and design patterns.
That's important.
Like what role do they play in all this?
Well, so think of design patterns as like the architectural blueprints.
Okay.
For our Lego city.
Oh, okay.
They're kind of like the best practices and guidelines that make sure that our city is well structured and that everything works smoothly together.
So it's not just like randomly throwing Lego pieces together.
Exactly. You need a plan. You need some structure.
So it's like the building codes.
Yes. Like the building codes and the zoning regulations.
That make sure that nothing falls down.
Right. And that everything is safe and functional.
And that like the electricity works and the plumbing works.
Exactly. And then it looks good, too.
And that it's not just like an eyesore.
You want your Lego city to be beautiful.
Yeah. You want it to be functional, but you also want it to be
aesthetically pleasing.
Yeah, aesthetically pleasing. So there are a bunch of different patterns that the guide talks about. One that kind of jumped out at me was the API gateway.
Ah, yes. The API gateway.
That sounds kind of...
That's a very important one.
Important. Like what is that exactly?
So the API gateway is kind of like the front door to our Lego city.
Okay.
It's the single entry point for all incoming requests.
Oh, okay.
So any visitors that want to come into our city, they have to go through the API gateway.
So it's kind of like a...
Eureka Grand entrance.
Like a security checkpoint?
Yes, exactly.
Or a...
or a receptionist.
Yeah, receptionist.
Who directs them to the right place.
Oh, okay. And why is that important?
Well, for one thing, it simplifies things for the visitors.
Okay.
They don't need to know the addresses of every single building in our city.
Right.
They just go to the front door and say, I want to go to the Lego movie theater.
Right. And the receptionist knows.
And the API gateway will direct them to the right service.
Oh, okay.
It also helps with security because we can have all of our security checks at the front door.
Oh, okay.
So we can make sure that only authorized visitors are allowed in.
Right. And it
can also help with things like rate limiting.
Oh.
So we can prevent our city from being overwhelmed by too many visitors at once.
So it's kind of like
crowd control.
Yeah, crowd control for the
for our Lego city.
Lego city, that makes sense.
Huh.
Another one that I saw in the guide was service registry and discovery.
Ooh, that's a good one.
What is that all about?
So imagine that in our Lego city, all the buildings have their own phone numbers.
Okay.
But those phone numbers can change because buildings might move around or new buildings might be added.
Right.
So the service registry is like a phone book that keeps track of all the current phone numbers.
Oh, so if one Lego creation needs to call another Lego creation, they can just look it up?
They just look it up in the phone book.
Okay.
And then they can make the call.
And that's important because
things are always changing in our city.
Yeah, yeah.
We're constantly adding new services, removing old ones, scaling things up and down.
Yeah.
So the service registry helps us keep track of everything.
Okay, that makes sense.
Yeah.
There was another one that I saw that sounded kind of interesting. It's called the circuit breaker pattern.
Oh, yes. The circuit breaker.
What's the idea behind that one?
So think of it like a fuse box in our Lego city.
Okay.
If there's a short circuit in one of the buildings, the circuit breaker will trip.
Okay.
And it will prevent the whole city from blacking out.
Oh, so it's like a safety mechanism.
Exactly. It's a safety mechanism.
To prevent
cascading failures.
Oh, okay.
So if one service is having problems, the circuit breaker will stop any more requests from being sent to that service.
So it doesn't like overload it.
Exactly. It gives the service a chance to recover.
Okay. That's pretty clever. I like that analogy.
Okay, man.
All right, so we've got our Lego city design. We've got all the pieces.
We've got our blueprints.
We've got Kubernetes kind of making sure everything's running smoothly.
Right.
But where do we actually put this thing?
That's a great question.
Where do we deploy this?
So the guide talks about three main options.
Okay.
On premises.
Okay.
Edge and cloud.
Okay. So on premises is like
that's like building our Lego city on our own land.
Oh, okay.
So we own the land.
Right.
We build the infrastructure.
Right.
We manage everything ourselves.
So it's like
gives us a lot of control.
Total control.
Yeah, total control. But it can be expensive.
Yeah.
And it can be a lot of work.
And not as flexible.
Exactly. And it can be less flexible.
Okay. So edge deployment is like...
Edge deployment is kind of like setting up little outposts closer to our customers, closer to where the action is.
Oh, so it's like if you're... So, for example, if you're building an application for, Internet of Things devices, you might want to deploy your microservices on the edge so that they're closer to...
So that they're closer to the devices?
To devices, yeah.
And you can get lower latency.
Okay. That makes sense. And then cloud is kind of like...
Cloud is like renting space in a giant Lego convention center.
Oh. Okay.
So we don't have to worry about owning the land or building the infrastructure.
Yeah.
We just pay for the space that we use.
Oh, that's convenient.
It's very convenient.
And is that kind of the most popular option these days?
It's definitely becoming the most popular option for microservices.
And why is that?
Well, for one thing, it's very flexible.
Mm-hmm.
You can easily scale up or down as needed.
Okay.
And you only pay for what you use.
Mm-hmm.
And the cloud providers like AWS, Azure, GCP, they offer a lot of tools and services that make it really easy to deploy and manage microservices.
So you don't have to kind of reinvent the wheel every time.
Exactly. You can just focus on building your application.
Okay. I think this has been a really good kind of overview of kind of like the landscape.
Of the microservices world.
Yeah, of the microservices world. So, we've talked about containers and orchestration. We've talked about these different architecture and design patterns.
Right.
We've talked about the different deployment options.
And, throughout all of this, the guide has done a really good job of using real-world examples.
Yeah, I've noticed that.
To illustrate these concepts.
Yeah, it's not just a bunch of theory.
Exactly. They make it really relatable.
Yeah, they make it real. And I think the guide actually goes into a pretty in-depth case study of Netflix.
Yes.
The king of microservices.
Yeah, they're kind of like the...
poster child.
The poster child, yeah.
For microservices.
So, I'm kind of curious to hear more about,
how they've actually implemented this.
How they've actually implemented it. Like, what have they done...
In the real world.
To kind of, to be so successful with it.
Yeah, because their story is really interesting.
Yeah.
Okay. So before we jump into Netflix, though, I think, we kind of touched on it earlier, but it's worth kind of revisiting.
Sure.
This idea of communication between services.
Communication, yeah.
It seems pretty critical.
Oh, absolutely critical.
That they can actually talk to each other.
Yeah. If your services can't talk to each other, then you don't really have a system.
Right. You just have a bunch of
a bunch of isolated pieces. Yeah.
So the guide talks about two main ways that they can communicate. Synchronously and asynchronously.
Yes. Synchronous and asynchronous.
So synchronous communication is like...
it's like a phone call.
Okay.
You pick up the phone, you call someone, you have a conversation in real time, and then you hang up.
So it's like it's very straightforward.
Instant messaging?
Exactly. It's like instant messaging.
Yeah, and for
microservices.
Okay. And asynchronous is more like?
Asynchronous is more like sending a letter.
Okay.
Okay. You send your message.
Right.
And the recipient can retrieve it and process it later.
Oh.
When they have time.
So they don't have to be like right there.
Exactly.
Waiting for the message.
You don't have to wait for a response right away.
Okay. So it's more like a postcard.
Like a postcard or a letter.
Yeah.
You just drop it in the mailbox.
And then you just hope that it gets there.
And eventually it'll get there.
Eventually. Okay. And the guide mentions some technologies that are used for these different...
Yes. For asynchronous communication.
For asynchronous.
There are things like message brokers.
Okay.
And event-driven architecture.
Yeah. So what's a message broker?
So a message broker is kind of like a post office.
Okay.
It receives messages from one service.
Yeah.
And it holds them until a recipient service is ready to pick them up.
Oh, okay. So it's like a
holding area.
Yeah, holding area.
My messages.
Yeah. So even if like the recipient service is busy doing something else,
the message is just kind of like sitting there.
It's safe and sound in the post office. Waiting to be picked up.
Okay. And what about event-driven architecture?
So event-driven architecture is kind of like a party.
A party.
Yeah. Imagine you're at a party.
Okay.
And something happens.
Like someone spills their drink.
Yeah. Someone spills their drink, or the music starts playing, or someone walks in the door.
Yeah.
All of these things are events.
Okay.
And the people at the party can react to those events.
Oh, so it's like...
So instead of everyone constantly asking each other, what's happening?
Right.
They just wait for something to happen.
And then they react to it.
And then they react accordingly.
Okay, that's pretty interesting. So it's kind of like, instead of
pulling for information, you're pushing information.
You're just kind of like waiting for something to happen.
And then reacting.
Okay, that's pretty cool. So I'm kind of starting to see how
these different pieces fit together.
And I think the Netflix example is going to be a good way to kind of...
to see it all in action.
Yeah.
Yeah, because they use both synchronous and asynchronous communication in their system.
All right, well, let's take a quick break, and then we'll come back and we'll dive into Netflix.
That's good.
Okay, so Netflix. Everyone knows Netflix.
Yeah, pretty much.
I mean, they're like the
streaming giant.
Yeah, the streaming giant.
Mm-hmm.
So the guide talks about how they were kind of pioneers.
Early adopters.
Adopters, yeah, of this whole...
of the whole microservices
thing. So what can we learn from them?
Well, I think one of the biggest takeaways from their story is that microservices really allowed them to scale at an incredible pace.
Yeah, because they grew really fast.
Oh, insanely fast.
Yeah.
And if they had stuck with their original monolithic architecture, they would hit a wall.
Yeah.
They wouldn't have been able to keep up with the demands.
So they kind of had to rethink things.
Yeah. They had to re-architect their entire system.
And so how do they actually go about doing that?
Well, the first step was breaking down that big monolith into smaller, more manageable services.
So it's like they took that giant Lego creation and they were like, okay, let's break it up. Let's break it up into
smaller sets.
Yeah. And so what were some of the services that they created?
Well, they have services for pretty much everything, like streaming recommendations, user profiles, billing, all those different things.
So it's like each of those is like its own...
like its own little Lego creation.
Yeah, its own little Lego creation.
Mm-hmm.
And they can all kind of work...
independently. Yeah.
And that kind of gives them that...
flexibility.
Yeah.
And that scalability.
So if the recommendation service is like, having a problem...
right.
It doesn't bring down the whole...
it doesn't affect the streaming service.
Yeah.
People can still watch their movies.
That makes sense. So the guide mentions that they used an API gateway.
Yeah, they use an API gateway.
And we talked about that a little bit earlier.
Mm-hmm.
So how does that kind of fit into the Netflix story?
So for Netflix, the API gateway is kind of like the front door to their entire streaming empire.
Okay.
So all the requests from users.
Like when I'm trying to watch...
when you're trying to watch Stranger Things.
Stranger Things, yeah.
All of those requests go through the API gateway.
Okay.
And then the API gateway routes those requests
to the right place.
To the right microservice.
Okay.
So if you're searching for a movie, the API gateway will send that request to the search service.
Okay.
If you're, starting to play a movie, it'll send that request to the streaming service.
Oh, okay, okay. So it's kind of like the
traffic cop.
The traffic cop
Of the Netflix system.
making sure everything's flowing smoothly.
Yeah, exactly.
Okay. I think the guide also mentioned that they use a lot of asynchronous communication.
Yeah, they're big fans of asynchronous communication.
And why is that?
Well, because they have so much data.
They have a ton of data.
A ton of data.
Yeah.
Millions of users
Right.
watching billions of hours of content.
Yeah.
So they need a way to process all that data
Efficiently.
And that's where asynchronous communication comes in.
So what are some of the technologies that they use for that?
So they use message brokers like Kafka
to
handle a lot of that asynchronous communication.
So it's kind of like their
messaging system.
System, yeah.
Mm-hmm.
And so, what kind of messages are going through that system?
Well, all sorts of things, like user activity. So when you, pause a movie, or you rate a movie, or you add something to your watch list, all of those actions generate events.
Okay.
And those events get sent through Kafka to the appropriate microservices.
So it's like a giant
nervous system.
Yeah, nervous system.
For Netflix. It's sending signals back and forth.
That's pretty fascinating.
Yeah, it's really cool how they've built this.
I mean, it sounds like it's a pretty complex system.
Oh, it's incredibly complex.
But it seems like it's working pretty well for them.
Oh, it's working incredibly well. I mean, they're the leader in streaming for a reason.
Yeah.
And a lot of that is due to their microservices architecture.
Okay. So, I mean, this Netflix example, I think, really kind of
brings it all together.
Yeah. We see how they've used containers. They've used orchestration.
They've used API gateways.
Message brokers.
Yeah.
Message brokers. All of this stuff that we've been talking about. It's all there.
It's all real.
And it's working.
And it's working.
At scale.
Yeah. Okay. So, as we kind of wrap up this this deep dive into microservices, what are some of the key takeaways?
I think the biggest takeaway is that microservices are not just a technology.
Right.
They're a way of thinking.
Oh, interesting.
It's a different way of approaching software development.
Okay. So it's like a mindset shift.
Exactly. It's a mindset shift.
Okay.
It's about breaking down complex problems into smaller, more manageable pieces.
Right.
It's about embracing flexibility and agility.
So it's not just about, picking the right tools and technologies.
It's about changing the way you think about building software.
Right. You got to change the way you think about it from the ground up.
Yeah.
Okay. So it's a bigger change.
It's a bigger change than just, learning a new programming language.
Yeah. It's a cultural change.
Oh, wow. Okay.
It's a change in the way that your teams work together.
Okay. Well, I think that's a really good point to kind of end on.
Yeah, I think so too.
I mean, this has been a really interesting deep dive.
It has been a fascinating journey.
And I think we've learned a lot.
I've learned a lot.
So thanks for joining me.
My pleasure.
And I hope everyone listening has gotten something out of this.
I hope so too. And if you want to learn more,
there's
tons of resources out there.
This guide is a good place to start.
Absolutely. This guide is a great starting point.
Yeah. And there's, tons of other stuff online.
Yeah, there's conferences, meetups, blog posts, all sorts of things.
Yeah, so keep learning.
Keep experimenting.